Oh, there we go.
They don't have a computer red, green, blue.
Woohoo.
Oh, so it's fine now. Okay.
I guess all we need to do is what was
It wasn't set up right.
Thanks. All right, we're going to go ahead and get started. This presentation is called Smoke and Mirrors. It's going to be looking at security through obscurity. You can actually move through. Standard disclaimer that this is not reflective of the opinion. What we're saying is not official opinions by PhreakNIC, SRA, which is the company we work for, or any other future or present bosses. So about us, my name's Adam Meyers. This is Dan Van Bellingham. We're security consultants. We work with the federal government mostly, doing all types of security assessments and pen testing and stuff like that. We're part of a penetration test team, or more to the point, we are the penetration test team. We're both CCE certified forensics people. We do security architecture, and we're both buffalo chicken wing aficionados. That's us. All right, so the agenda that we're going to go through is what we've entitled Smoke and Mirrors is really security through obscurity. And we're going to go through why security through obscurity is bad. And then we're going to go through why security through obscurity is good. We're going to talk about crypto versus like the military intelligence community's perspectives on obscurity. Sorry. We're going to talk about best practices and better practices. And we're going to go through what S&M security, smoke and mirrors, can accomplish. Protecting the network, hiding assets, things of that nature. And then we're going to talk about how to implement it down to the code level in some instances. And then some other techniques that kind of fit in. So, oops. Stupid cable. Oh, there we go. All right, so Dan's going to go through some of the different aspects here.
So I did a quick search, security through obscurity, and right away things come up, why it's bad. One of the things that popped up was an RFC by Steve Bellovin and Bush, written a couple of years ago, that went through a couple, based on the premise that security through obscurity is bad. You don't want to try to hide vulnerabilities. It's really saying things that you want to keep discussions of vulnerabilities open. By people discussing open vulnerabilities, it helps people come out with ways to prevent against those vulnerabilities and how to fix them. So the whole idea of having things on the open side is better. A lot of the crypto weenies really come across based on things like Kirchhoff's law, is that you really want your systems to be open. The only thing secret about a crypto system should be the key itself. That way, all the crypto weenies in the world can bang on the algorithms, and then once they do that, they can all agree together that it is a secure algorithm. By keeping things proprietary, then everyone kind of shouts out saying that there must be flaws because you're not telling us how the system really works. So that's why security through obscurity really gets kind of a bad rap, is by saying it's really kind of based on the crypto school of thought, is you want to keep your architectures open and not closed. Adam said we do a lot of consulting for the federal government, DoD, some intel agencies. In that type of community, security through obscurity is good. That's what they're taught. You want to keep things secret. You want to keep there's certain information that you have that you don't want your enemies to know. In World War II, there was a big campaign, loose lips sink ships. Right? You didn't want people writing about where they're going, where they're being deployed. That type of information could affect the soldiers and the military. A lot of our strengths in World War II came from the fact that we were able to crack a lot of the code that was being sent around the world, and that gave us an advantage over our enemies. It's also in the military, everything's based on the need to know. What information is out there. Certain people, you may have a security clearance, but you may not have access to that information. So it's all based on need to know. So again, from this perspective, security through obscurity is a good thing. This is what people are taught. In the software engineering community, software code obfuscation is a common practice. Right? They try to do this to help prevent against reverse engineering. So there's tools, utilities, there's even classes taught on how you obfuscate your code to help prevent against people reverse engineering and then taking your code away. There's even contests out there, International Obfuscated C Code Contest, there's a Perl contest. You have here's an example. I think I pulled this one down off of Wikipedia, based on the last. I thought I'd just say that based on the last talk. Anyway, so this one comes up. This is actual code that generates 12 verses of the 12 days of Christmas. Just to check it out, we ran it through, and here's the output. So, but the code actually does work. So this is common practice in the software engineering community. So we're going to build on just some basic best practices for security. This is nothing new for most people here. Doing things like patch management, having strong passwords, good passwords, teaching people not to use things in the dictionary. Again, Adam and I do a lot of pen testing for the federal government. I think last summer we were able to break into 2 CIOs accounts, 2 federal CIO accounts, based on their passwords. One was soccer. Anyway, good perimeter security, having IDS, IPS, using good access controls, educating your users is key, and then being able to secure configurations, having good configuration management, locking down unnecessary services, stripping things out. These are all kind of textbook best practices for security. That builds into what we call even better practices. So doing things like honeypots, obfuscating web server application error messages, tuning your IDS in ways that you can help strip out some of the false positives and false negatives. Going through consolidating your logs across all your devices, applications, even network nodes. Doing good code reviews, limiting access to scripts, CGI, and other scripts internally developed. Again, most scripts and code that's developed internally isn't put through the same measures as it would be normal open source community. So things internally you really want to have restricted access to. And then just doing regular assessments. Things are dynamic environments.
All right, so what can it do? I mean, we really haven't talked about what you're going to do with this stuff now. Using the smoke and mirror technique, you're going to obfuscate your network architecture. You're going to obfuscate your code. You're going to obfuscate target services. So you want to get the attackers to reveal themselves without actually penetrating the network. Some of the best attackers can be fooled by this method. And what we're about to present is stuff that we've picked up in doing testing and doing security assessments, stuff that we found people are doing and has actually aided in their ability to protect themselves and defeated us in being able to find some of this stuff right off the bat. Script kiddies probably won't catch on and probably won't even care if they find an IIS exploit and they think you're running IIS and the exploit doesn't work. Chances are they're going to move on to the next target. It's going to cut down on IDS alerts potentially, and hopefully lure malicious users into revealing themselves because they're going to be tricked into doing something that they wouldn't ordinarily do. And it can increase the level of effort and time that an attacker is going to need to penetrate a system, while also lowering the time that it's going to take for a response team to actually respond to the incident, because they're going to be able to go in for things that are definitely targeted attacks and just brush the rest of the bullshit away. Can I say that? I just did. All right, so basically the theory, kiddies are going to use the path of least resistance. They're not going to go after a target that's more difficult for them to attack. They're going to go after something that they have an exploit for and they know they can get in. Any security measure at all can pretty much deter a lot of the script kiddies that are out there on the net. Real attackers will probably attempt to limit their recon signature, and by limiting their recon signature, they're probably going to pick up a lot of this smoke and mirror servers that have been obfuscated and the services that have been obfuscated. Chances are if they're doing any sort of differential scanning, they're going to need to use decoyed hosts, and it's going to take a long period of time, and that's going to limit the amount of time that they're going to have to do actual recon. And generally, I mean, they're going to go after low-hanging fruit. So if there's something that looks clearly vulnerable, chances are they'll probably try and hit that. All right, so basically the two things that we're going to be going into is misdirection and sleight of hand. Now this is all stuff that a lot of you are probably doing. It's probably not going to be anything earth-shattering to you, but it's kind of a good collection of things that you can do in order to better protect a network. Things like changing OpenSSH to WinSSH, or make up some other, you could use SSH commercial or something like that. Changing SendMail to Exchange, Apache to IIS or WebSphere or something along those lines. Moving Oracle's port, changing the Oracle port to look like a SQL port is going to change you're going to see a change in what people are trying to do to the system, and really you shouldn't have that out on a networked, a routable IP anyway. And then sleight of hand, open services associated with the vulnerability, and run netcat on them so that you can kind of try and trick people into running an exploit on what they think is a vulnerable service. Routes to nowhere, kind of like using things like La Brea tar pit to really bog down an attacker. And then everybody in here heard of Port Sentry? It's really cool Perl scripts that basically they open up a port, and when an attacker tries to hit that port, it blackroots them. What's that? No, it's from Psionic, or PS Psionic. I don't know how to pronounce it, but it's free to download, open source. They also have Host Sentry, which runs on the host, and Log Sentry, which does some sort of log consolidation. So now that when you start implementing these things, you're going to have to take other things into effect, take them into consideration, things like your IDS. So some of the things you can do once you've implemented some of these obfuscation techniques is going to be ignoring irrelevant attacks entirely. So if you know that you're running Apache, you can pretty much stop looking at IIS attacks. That's not something we'd recommend, because the way that we consider it is that ISS attacks now take on a new classification, in that it's somebody that fell for it, and they're going for this IIS server that's actually really Apache, but you've changed the header. It's basically a good way to obfuscate that. Watch for repeated attempts to attack a network. You can create high priority alerts for valid services. So you can, kind of what we're saying about giving it a new classification, you can give a new priority to some of these attacks that probably don't have anything to do with you, but it'll show you that somebody's actually taken the time to do recon. They think they know what you're running, and now they're attacking it. You can correlate recon and attacks without exposing services to the attacker, so that clearly if they think that you have SQL running and they go after it, you know that they've actually done some homework and they saw where it is. And if anybody has any questions while we're doing this, just feel free to raise your hand. So network service S&M, we've got a quality picture of Monty Burns up there. So we're going to go through some of the different services that you might be running, stuff like Apache, IIS, SSH. Okay, yeah, you probably don't need to go through that anymore. So really simple example is URL scan. It's free to download, provided by Microsoft. You can do things like change the 404 errors. You can change the server identification strings. You can, there's all kinds of different permissions that can be set on it. It's simple, it's free, and it's effective. And if you happen to be running IIS, this is a great way to do this.
Is Microsoft really distributing a package that makes their servers look like Unix servers?
Well, it supports doing that. All right, with Apache, you can do the same stuff with Apache. You can do change error messages. You want to change your 404, your 502s, stuff to obfuscate what version of Apache you're running, or even that you're running Apache if you want. Change the banner to report IIS. Another cool technique is grabbing some of the error pages from IIS and throwing it into the Apache errors, and that way you can kind of really convince somebody that you're running IIS. So here's a Apache server example, and this is probably should have put the file name here. This is a file from the source code, and in it defines the Apache server, base vendor, base product, major revision, all this stuff. So by simply changing this to be like that are up there, changing it to Microsoft IIS 5.0 and then a build level like 2193, doing an mmap scan, a version scan against this, you're going to actually see it come back as IIS Web Server 5.0. And that's typically resulting from a banner grab. And an attacker sees that, obviously they're going to think that you're running Microsoft and maybe try and do some front page attacks or something like that against your system. Another suggestion to kind of obfuscate this, using something like Simple Secure Web Server. If an attacker hits that, they'll kind of come to the conclusion that you're probably running Raptor Firewall version 6.5 or lower, tricking them into thinking that there's an application firewall. Potentially, you're going to see Raptor-specific attacks. And then an IDS alert, obviously triggering that, was something that you can look for very easily. So changing it to a vulnerable Apache or IIS, if you want to get a specific exploit as an IDS alert, if you have a vulnerable version and you see an attacker use a readily available script, then it's pretty easy to see who's trying to attack you and not put yourself at risk. And it's always a good idea to spoof another product because a lot of stuff like Metasploit, which has it support multiple versions, shellcode for multiple versions. They might get lucky and you might get owned. So I wouldn't recommend just changing the version number. Here's a copy of OpenSSH. There's I think it was version.c. Just has a couple of definitions in it, so you can change that to whatever you want. And once you compile, and for a lot of the stuff, you definitely want to compile from source anyway. So once you compile it in, it's going to actually build that as the banner and the fingerprint. So if you scan through. Now, because there's no actual WinSSH service, it comes up as unidentified, but it actually, you could see that it comes through as WinSSH right there. So an attacker might think this is a proprietary SSH implementation or just really be confused. So, I mean, this is a Linux box right now or BSD box that's running, Microsoft IIS server, and changing the postfix. I set it to postfix, but if you change that to Exchange, you can pretty much convince somebody that this is a Microsoft server. Here's the postfix version file. Again, it's kind of getting redundant, but all of these things have version files, and you just go in simply and change the version file. With something like IIS or some of the binary executable products, you kind of need to use a hex editor and try and track this stuff down inside of it. A couple of search scripts should be pretty easy to find where the version number is. And if you change the version number, just be careful that sometimes you need to have the exact same amount of characters for the server to run. And WUFTP, there's actually a shell script in that called newvers.sh, and what it attempts to do is to put the build time into the compiled executable so that you know when it was built. You can change this to do whatever you want, and if you drop the %d with the time stamp, you can actually just drop all that, and you can make it look like Microsoft IIS FTP. So now that we've kind of talked about some of the different services that you can change, we're going to talk a little bit about protocol smoke and mirrors, things that you can do at the protocol level to obfuscate what systems you're using, and in the case of ICMP, where you're located. You can change the time zone, or you can change it to a different time zone, or you can change it to UTC. There's different reasons for each. Changing the time zone, you can convince people that you're in one time zone, and then as attacks start coming in for that time zone, if they're attacking at night, it'll actually be in the middle of your day, and you have a full staff watching the IDS. For TCP, stuff like randomizing the ISN, which comes out of the kernel, proxy traffic to change the TCP fingerprints that people are using. Like, if anybody is using like POF, if you're familiar with that, that actually does client-side fingerprinting. So you can filter all your traffic through a proxy and change the TCP stamps and kind of make somebody think you're using a different firewall or something of that nature. And then breaking RFC compliance is definitely an issue you want to be aware of if you start messing with the TCP stacks or you start actually going in and changing stuff in the kernel code-wise. Databases, same thing. Obfuscating the port. You can go, Oracle 1521, move it to 1433. Chances are people are going to start thinking that you're running SQL versus Oracle. Setting up fake SIDs. If you set up SIDs that are usually associated with things like PeopleSoft, an attacker might be going after a PeopleSoft implementation vulnerability or something of that nature, while they're missing that there's actually a SID for whatever it is that the database is doing. So stuff like that, going to trick people. Changing the application headers, a little bit more difficult, especially when you start dealing with Oracle and SQL, but still potentially possible. Does anybody have any experience with that? Nope. Okay.
Yeah, well, another thing you can do is try to have ambiguous usernames, making it more difficult for attackers to learn about the organization. Scrolling through news groups or other things online, trying to find how user accounts are set up to get more information about a target is one way. So instead of just having J Smith, if that's a typical username convention, J Smith, you may want to mask that as Joe.Smith or Smith J, or even something really ambiguous like J and some random number string. Using email gateways allows you to do aliasing. That's one way. So if you are using individual email accounts, you can, before they come out of the gateway, you can change all the username conventions to something standard, so everything looks like it comes out with one standard email name convention versus how you have the user account set up on your systems. Okay. And other thing on the host level itself, you can try to change log file names and where they're located. Not keeping things in the default locations is one way to do that. Changing your default admin accounts, changing things around from root or a guest. Chatter plus I files. By changing the different immutable flags, you can help keep the integrity of your system valid until someone really wants to change that file. Even having this. Yeah.
I have a good anecdote about that. I was on a system where I had been the admin, and I had set the shadow and the password files. I set the immutable flag using Chatter, and like a month later, the person who actually got root after I stopped using that system called me up, and they were like, "What the hell did you do? We can't actually access the password file." So stuff like that will confuse attackers. That if they get in, you can actually kind of throw them off, and they might be like, "Well, I have super user privileges. Why can't I write to the file?" So that's a good way to kind of trick people up a little bit.
You can do strange things to your file structure, having directories that don't really lead anywhere. And then even on your production systems, we like to do things like just go through and remove all the command line interpreters from the system and the compilers. So if people do get onto the system, they're limited to what they can really do with that. Another things we can do, like simple things with Wi-Fi, having misleading SIDs there. You really want to have ambiguous names. And we see a lot of people setting things up in DC with the name of the organization, even things like Bank of America on their SIDs. It's typically a bad thing. Decreasing the beacon rate, another thing, or even putting up decoy access points is another way to obfuscate your wireless presence. I think it was the Republican National Convention did that, where they had a kind of blanket statement saying we're going to have any wireless at our convention. But what they did do is they put up decoy APs to see who was actually trying to get on the wireless network, so they could go and tell them to stop. With dial-up, you can do the same type of techniques with banner changing, taking the version numbers off, maybe not putting the name of the organization on the banner when it comes up. Another thing to do is do open source intelligence on yourself and your organization, going through, looking up, find out what's on Google, what are people posting about you. We're able to, a lot when we do our testing on different government agencies, we're able to pull a lot of information about the agency before we even get there. A couple of years ago, we were doing some work for EPA, and we were able to find information from different vendors that had done success stories about the EPA and their new data center. So before we even walked into their data center in North Carolina, we knew that they were running IBM mainframes, we knew they were running DEC Unix, we knew they were running Oracle databases all in the back end. We had a lot of information about the organization even before we walked in, just from what people were saying about them and what's being posted on the internet. So it's good to go through and do searches for yourself on a frequent basis. People are posting things all the time that changes. So even if you do this, one quarter, you may want to do it the next quarter, maybe even monthly.
Oh, and then stuff like Google hacks. Everybody's seen that Google search where you search for the string from the webcam, and then you can just start pulling back webcams just straight through Google. Even if they're not listed, it's just an IP address. It'll have the webcam there. Stuff like that you want to try and obfuscate as well if it's possible and you happen to need a webcam that's on a routable IP address. So essentially wrapping it up, though, security equipment is really expensive. IDS really expensive. These things cost upwards of $50,000. Most of us can't afford that. Doing this type of technique, it's free. It's really easy to do. There's really no maintenance once you've done it, and most of the tools needed to implement it are already there, so you might as well use them. One of the things that we wanted to kind of open up to the general public is we're going to start trying to collect good obfuscation techniques. So if anybody has good obfuscation techniques that they're already using, we're going to try and open up like an open forum for getting the best, like an industry best practices for obfuscation. So feel free to contact us as far as any good techniques that you might have. And then I think that's almost it. Also, if anybody's looking for a job, we're always looking for good qualified pen testers and code reviewers and stuff like that. So if you are clearable, feel free to come talk to us offline or whatever. We'll be wandering around the convention for the next couple of hours at least. And then questions, answers. Anybody have any comments, stuff they want to talk about? All right then. Is there a danger in this becoming so commonplace that everybody knows it? Not really, because then they still have to figure out what you really have going on behind the scenes. And then you could start doing, the opposite will soon become true, that if you don't, it'll help protect other people, because if they don't do it, an attacker might assume that they are doing it, and then, go to great lengths to try and figure out, I know it's not Apache, it can't be Apache, and then all of a sudden it turns out that it really is Apache. So you kind of, I think that there would be more of a movement towards security as a whole, and that other people would be subject to some of the benefits of a mass obfuscation across the internet. Okay. Well, thanks.